Now that you understand the basic construction of animation, you can use it to animate anything you can draw on the screen. Here is an example of animation that's one step up from the circle moving right and bouncing off the right side. This is a circle that moves in all directions and bounces off all four sides. Now this one has a few more declaratives to hold values, but that's because the motion is more complicated. There's just more to keep track of. The motion is managed here in the run method by keeping track of the X and Y positions of the ball. The thing is always moving either up or down, and it's always moving either left or right. If it's moving right, its current X position is incremented until it reaches the maximum right position, and the horizontal movement is then reversed. If it's moving left, that continues until it reaches the left side of the window, so that it moves back and forth. The vertical motion is handled in exactly the same way. When it reaches the bottom, the direction is switched to moving up, and when it reaches the top, the motion switches to moving down. The paint method just draws the ball at the current position, whatever that happens to be. Here's the result. The ball bounces off all the edges. Resizing the window causes the rectangles to no longer match, so it starts the whole thing over with a new size. Here's another example. This one animates several balls at once. Like all animation programs, this one has quite a few declarations. Also, notice the arrays in this one. This is necessary because this program animates a number of items simultaneously, and each one has its own position, trajectory, and color in the window. And all of these different variables must be tracked for each one. The program is called Electrons because it animates several objects in elliptical orbits around a center. You can see from the setting of electron count that there are 14 of them. There is some trigonometry involved in keeping track of the orbits, but I won't go much into that. I just want to show you how several things can all be managed at once. Here in the constructor, the colors are set. There are 6 colors defined, and there are more electrons than that, which means that some of the colors are used more than once. Each electron is assigned a color and a value ranging from 0 to 5. Just as with the previous animation programs, the frames are controlled by the calls to the update method. If this is the first time this method has been called, or the size of the window has changed, the first frame method is called to initialize the position and orbit of each electron. If it's not the first time through here, a call is made to next frame to update the position of each electron. Finally, the paint method is called to update the buffered image, and the buffered image is then written to the displayed window. Here is the paint method. It begins by clearing the display to the background color. Then there is a loop that displays each of the individual electrons. It starts out by setting the color for the current electron, then sets the values of X and Y. I'm not going to explain all the theory behind the math, except to tell you that the orbit is elliptical, and the array named A contains the radius of the electron's orbit in the horizontal direction, and the array named B contains the orbit's radius in the vertical direction. These values are multiplied by the values of the sine and cosine of the current angle, and that results in the current X and Y rotation position of the electron.